All right, we are going to start solving quadratic equations by revisiting the zero product property, and we are going to look at solving by taking a square root. So there's actually two things we're doing today. The zero product property is a little bit of a review, um, and we start out with a problem that an application problem, and this is a good problem to look at. Physics teacher put a ball on top of a ramp and let it roll down toward the floor. The class determined that the height of the ball could be represented by the equation h equals negative 16t squared plus 4. Now, obviously, we weren't there yet in terms of what that equation is, but we could figure that out. Where the height is measured in feet from the ground, this is h, and time is measured in seconds. So time is how long does it take to go this direction. What do you notice about the structure of the quadratic expression in this problem? This actually looks like it's a difference of squares, but it isn't quite a difference of squares because it isn't a subtraction sign the way we know it. So, notice that it's missing the middle term. That means it's going to be uh, on the y-axis. The vertex is going to be on the y-axis. In the equation, explain what the 4 represents. Well, that 4 right there, doesn't that represent the height that it starts at, right? And let's see, measured in feet, so we probably should put feet here. All right, explain how you could use the equation to determine the time it takes for the ball to reach the floor. That's interesting. Now, we could factor this. We know that when it hits the floor, right, h now is 0. So we would like to solve and set h to 0. So if I'm working on C right now, if I say 0 is equal to negative 16t squared plus 4, what we know is that we could factor out a common factor and go from there. Or we could just try to solve it. But let's do it that way. Negative 4 comes out. That leaves 4t squared minus 1. Now that's a difference of squares. Do you recognize the difference of squares? I hope so. Negative 4, this becomes 2t minus 1 times 2t plus 1. And we know that if this is set equal to 0, then either this is 0 or this is 0. So trying to solve that, we got 2t minus 1 equals 0, or 2t plus 1 equals 0. 2t equals 1, or t equals 1/2. Over here, 2t equals negative 1, or t equals negative 1/2. So then you got to ask yourself, is it reasonable for us to go back in time? No. So we know that it's going to take half a second to roll down that ramp and reach 0. All right. Hopefully that makes a little bit of sense. Hopefully we can work with equations and solve problems. Okay, so we've been factoring these, and in the past we've set equations to 0, so we're familiar with this. What is the y value of all x-intercepts, right? All x-intercepts. Well, won't the y value always be 0? And the question is, are there any exceptions? The answer is no, but wait a minute. What happens if your parabola doesn't hit the x-axis? So in that case, there won't be any x-intercepts. So the answer still is no. It's either going to be no or it's going to be something that we don't quite understand yet. So clearly that doesn't hit the x-axis. So y does not equal 0 in those cases. All right, and then we jump down here to the zero product property. Then we know either a equals 0, b equals 0, c equals 0, or d is equal to 0. They don't all have to be 0, but any one of them can, and so those are reasonable answers for our solution. This just goes back and reviews what you already know. I'm going to skip the first couple. We know for 6, c is either equal to 5 or c is equal to 0. Right? Over here for 7, c minus 5 equals 0, therefore c equals 5, or d plus 3 equals 0, so d then has to equal negative 3. That's our zero product property, and a quick reminder of what all that's about. Okay, so we're taking a look at that equation. You saw me solve this differently, and we already know that this turns out to be 1/2 and negative 1/2. But over here, they said, let's solve this by the square root method. Okay, so if you need to go back in the video and review this, hopefully you understood that. I solved that in another way on the previous page. This one says, hey, what if I took and moved 16t squared over to the other side? Okay. And then I want to get t by itself, so I divide both sides. Divide both sides by 16, and I get t squared equals 1/4. Now I got to get t, so it's only t. And in order to do that, you're going to take the square root and the square root. The square root of t is t. Now here's the problem: is you got to consider, when you take square roots, you got to consider both plus and minus 1/4. Well, plus or minus the square root of 1 is 1, the square root of 4 is 2, or 1/2 and negative 1/2. That actually is easier if the middle term is missing. You'll notice that this problem, A and B, are the same problem, solved two different ways. Let's go ahead and do that. I'm going to solve 9, which I want you guys to stop the video and try. All right, so hopefully you had a chance to work this and you can factor this. Remember, this is a difference of squares, so you shouldn't actually have to be factoring these now. Number 9 for part B says let's factor by taking the square root. Let's work this together. All right, so I'm going to add 108 to both sides. Whatever's negative, take to the other side. And if you want, you can leave it. You can flip it around, but 108 is equal to 3x squared. If I divide by 3, or by 3, sorry, I get x squared equals 36. If I were to take my square root of both sides, now remember, when you take the square root, you have to consider plus or minus. X is going to equal plus or minus 6. Clearly that is easier, I think, if the middle term is missing. All right, your turn. I'll let you work both of these, both methods. Try both. I will work them and show it to you in a minute. So now the question is, which way is easier? And again, it's probably worth taking a minute to stop the video if you missed one of these or the other. Notice that you end up with the same answer in both cases. All right, so we're going to work through this problem and we're going to justify each step along the way. The video is getting long, so I'm going to let you work this and I'm going to go show a step or two as we go. Um, if we're going to solve this, clearly from here to here, v equals 0. This allows us to use our zero product property. Next, we need to isolate. Okay, from there, I've got to divide by negative 24. And that has isolated um, the, the parentheses. So take the square root of both sides, and when you take the square root, don't forget you got to end up with plus or minus. So we're going to add 5/2 to both sides, and when you do that, notice that you end up with 5/2 plus or minus 5/2. So now you know what h is. H is going to be two different things. And notice that as you simplify here, you end up with two answers. Either h is equal to 5 or 0, and you're pretty much done. One step at a time. All right, take a minute and try a couple of these problems. I'll give you the answers here in just a minute. So stop the video and try these. Okay, so I worked the first one, gave you the answers to the next two. If you're having trouble, let me know, you guys. Okay, so I think there are 5 problems here that I think we ought to work. I'm going to work 18, 20, 22, 24, and 26 for you. You might want to try them first and see if you can solve them. These are all slightly different. I will work them and then show you. All right, so the first one was you had to group and factor, and notice that I ended up switching the 2 and 3 because I like factoring those out. Won't matter. It'll come out the same either way if you don't switch them. Number 20, you had to add the 5 to both sides in order to solve this. And again, you end up with positive 3 and 8. Notice it's just opposite of what's inside here. All right. 22 and 24, again, I'm going to stop the video. Why don't you guys do the same and try these, see if you can solve them. Okay, so again, you had that 7 on the other side. You had to bring it over. Hopefully when you factored out the 7, hopefully you factored it out, you recognized a perfect square, right? If not, you factored it the long way. Either way, you ended up with x equals 1. Number of ways of doing this, you guys. Don't get stuck on just one method. There's several methods for knowing how to solve these. 24, you had to subtract again the 29, and you ended up with a difference of squares, which x equals plus or minus 5. Last problem, I think, is again what we learned today. I'd like you to solve this by taking the square root, and I'm going to have you stop the tape and give it a shot. Okay, and again, solving by square root meant you had to isolate the square, take the square root, and then down here, I don't know if you really need to write this down. 3 plus 3 is 6, negative 3 plus 3 is 0, and you solve that. All right. You have enough information to work homework. Good luck. Let me know if you have questions.